Hi, I'm Hanna Dremalla and I'm leading the Multimodal Behavior Processing Group here at the Center for Cognitive Interaction Technology at the University Bielefeld. In our group, we are focusing on analyzing and interpreting social interaction signals. The goal is to develop empathic artificial intelligence to recognize and react adequately to a user's state. We focus on three areas: stress, affect, and social embeddedness. And stress affects behavior, cognition, and health. Therefore, we aim to detect it computationally, and Matthias Norden is working on this project.
In our current stress project, we are developing digital tools for the investigation of acute stress responses, for example, using laptops or smartphones. Normally, in traditional stress research, standardized laboratory protocols are used to investigate the influence of acute stress. But the problem is, these tests are not scalable and are very time-consuming. So, for example, during the Trier social stress test, participants need to come to the lab, give an interview in front of a jury, and are evaluated by the same jury.
Is this enough, or should I continue further?
Please go on.
Okay, let me think for a moment.
This test has shown to induce a physiologically relevant stress response, increasing stress hormones as cortisol, blood pressure, and heart rate measurements. In our group, we are now aiming for more scalable and modern ways to do stress research. That's why we adapted the principles of classical stress research and developed a digital stress test. This test can be conducted via the internet without any experiment or further equipment required. It allows us to perform stress experiments all over the world, including different cultures, age groups, or clinical cohorts. At the same time, we can collect a large database of videos capturing stress-related behavior. Using these videos, we want to develop algorithms that detect physiological stress responses from the face and the voice.
Similar to stress, positive and negative affect motivates and directs our behavior. Detecting it by computational methods allows us to react, feedback, and monitor effective changes. Therefore, William Sakyan is working on that project. Hi.
Hi. In our project, we use machine learning to recognize human emotions, or more broadly, affect. In cooperation with Humboldt University Berlin, we use interactive paradigms to record multiple aspects of human interaction behavior, such as facial expressions or voice modulation.
Hallo, mein Name ist Anna-Luise Kisch. Und wie heißen Sie?
Hallo, mein Name ist Steffen Johannknecht.
This can help to detect differences in nonverbal behavior and changes in psychological conditions, can support in diagnostic processes, can be used in smart homes, clinics, and so on.
Affect and stress are important influences on the individual. However, humans are social beings, and social interactions play a crucial role for well-being and mental health. And Oya Hakobian is investigating this role. Hi.
Hi. In our social embeddedness project, we aim to better understand the role of social interactions for health and well-being. As social interactions are often reflected digitally, we use online data for our analysis. For that, we first ask people to donate their data from Facebook and WhatsApp. Importantly, only metadata is collected so that the message content is not visible and the identities of all people are anonymized. We next use psychological questionnaires, graph analysis, machine learning methods to see how certain interaction patterns correlate with social embeddedness, resilience, and so on. Our goal is to better understand the role of social interactions for the development of psychiatric conditions and identify adaptive and maladaptive patterns.
Extracting social and affective information is just the first step for empathic AI. The next step is to use this information and feedback it to the user. And Dr. David Johnson is working as a postdoc on this step. Hi.
In the project The Sound of Facial Expressions, we aim to assist individuals with disabilities such as autism spectrum condition or visual impairments have more empathetic interactions. Typically, these individuals have challenges processing facial expressions such as a skeptical smile, which are so important during personal interactions. We aim to actually address this challenge by using a cross-modal approach and turning facial expressions into sound. For this sonification project, we're working with the ambient intelligence group of Dr. Thomas Hermann, who have actually already developed some sounds to help children with autism spectrum condition express their emotions. So for example, for a child to express happiness, they could play the sound, or for sadness, or for anger. So in the end, we aim to build on this research to provide and explore new methods to allow these individuals to have more empathetic and personal interactions.
Besides research, we offer teaching and supervision for undergraduate and graduate students. So we combine theoretical input and practical exercises. For example, last semester, we did a seminar where the students analyzed their own video regarding affective signals.
We also supervise master theses and individual projects. For example, last semester, some parts of the digital stress test have been developed as part of a student project. And another student developed a control condition that has been tested in a big online study.
Yeah, and in the upcoming semester, we'll be offering 2 new seminars regarding multimodal behavior processing and machine learning. In our Bias in Machine Learning course, we'll discuss how machine learning models can be discriminatory, the effects it has on society, and recent state-of-the-art approaches to address those challenges. We're also offering a Hot Topics in Multimodal Behavior Processing seminar as a journal club format in which students will read the most recent papers and be able to discuss those with research experts from our research group.
In our multimodal behavior processing group, we are always looking for talented students. So if you are interested in writing your thesis, doing an internship, or starting a PhD in our group, then you can check out our website or just directly reach out to us.